Topic, probability. This is section 9 of the foundation course. Probability. I'm working on the background of this beautiful cross section through a massive tree, an old tree. You see the rings there, it looks ever so beautiful, so I'm going to have fun writing up against that. Certain words used to describe probabilities: impossible, unlikely, evens, likely, or certain. So jumping straight in, an example of something which is impossible, it will never happen, is, I don't know, if I've got Tuesday today, Monday tomorrow. So somebody asks you, what is the probability that if it's Tuesday today, it shall be Monday tomorrow? The answer is impossible. Unlikely. Here's an unlikely event. It shall be 20 degrees C on Christmas Day. Why is that? Well, we're in the winter. You're unlikely to reach temperatures of 20 degrees C in the UK on the 25th of December. So unlikely, you can't say it's impossible. It's just an unlikely event. So that's quite descriptive for that one. Evens, I mean a classic here. If you take a coin, any coin, its heads on one side, tails on the other, provided it's not a dodgy coin, the probability of flicking and getting a head is evens. The probability of flicking and getting a tail is evens. Why is that? There are two possible outcomes for the event flicking a coin, and you could get head or tail. So what is evens? The probability of a head on a fair coin. Excuse me. Alright, likewise the probability of getting a tail on a fair coin would also be an even chance. Likely. What's likely to happen? Let's think of another weather one. Rain in spring. It is likely to rain at least on one day during the springtime. How's that? Very likely even. But likely is good enough. Certain. Going back to our days, provided the world does not end, if it is Saturday today, it will be Sunday tomorrow. Alright, that won't suddenly change back to Friday. So if it's Saturday today, what's the probability it should be Sunday tomorrow? It's definitely going to happen. It's certain. There's others we could use, but at this level, let's just get used to the words: impossible, unlikely, evens, likely, and certain. So let's label each one of these. I don't know. 1, 2, 3, 4. 5 words for you to learn. Changing direction slightly, you can actually quote probabilities as decimals or fractions or percentages, and I'm sure in Key Stage 3 you introduced to a number line. So here's a number line, and I'm really looking at question 3 where the number line has been introduced. That's meant to be a straight line. 0 is a great place to start, 1 is a great place to finish, and 0.5 is right in the middle. Now, as I said, you can quote them as percentages or fractions or decimals. A half, well, that's 0.5, isn't it? That's otherwise known as 50%. 1, well, that's just still 1 as a decimal, but that is 100%. And etc, etc. Let's go for 0.25 as a probability. Well, that's going to be a quarter, otherwise known as 25%. And this one, predictably so, 0.75, that's going to be 3/4, and you know that's 75%, don't you? And right, arrows. Let's go for black again. The event which is impossible will have a probability of 0 on the scale. So my black number 1, you see just there, I'm going to put right here. So here's example number 1, where the probability is 0. Unlikely, 20 degrees C on Christmas Day, unlikely. Well, it's not going to be right in the middle. It's not going to be an evens chance. Unlikely could be maybe here or even here, less than a quarter. So if I put 2 here, that's fine. All right. We should really put arrows. All right. So that's a little arrow to that one. Evens, the probability of a head coming up when you flick a fair coin. So 3 should go there, shouldn't it? Evens, put a little arrow to point to it. Next one, likely that it should rain in the spring. We can go for 0.75 or 0.7 or 0.8 or anything up here would be fine. Likely or even very likely, close towards the 1. So just put a little arrow there. We'll put our 4 there as a likely event. And finally, Saturday today, Sunday tomorrow. That's certain to happen. Let's put a little arrow exactly on the 1, and we'll put our 5 there as an example of that. Okay, plenty more I could have given. So that's the link between the words used in probability at a lower level and a slightly higher level when we're introduced to using numbers as expressing probabilities. Right, I think I'll pick up a question from over here. Yes, I think I'll do question 7, straight into the tricky ones, and I'll probably change pages now to give me some space. Gotcha. One more space. One more space. Go back. Ah, I think I used that one there. Good. Right. Question 7 on page 115 says this. Ross has 5 red marbles. So we're jumping straight into some decent questions now. So I've got 5 red marbles. He also says we have 11 white marbles. I should really be changing colour, but then again I might get it wrong and slow everything up. So 5 red and 11 marbles in a bag. Now if he picks a marble at random, in other words not deliberately trying to choose red or white, he just closes his eyes, shakes them up, picks them up and then just looks at it. What is the probability that it is red? Now let's look at this. Great shorthand this. The probability of getting a red, or R, is going to be 5 out of a total of 16. See, altogether we have 16 marbles, and the probability of getting one of those 5 reds is 5 out of the 16 that are available. Okay, that's all there is to it really. What is the probability that it is not red? Well, the probability of not being red has to be these 11 white ones which are not red. So it's 11 out of the 16 that are there. Now what does Jamie do? Jamie adds 4 black marbles. So let's go for black anyway. So I want to add 4 black marbles now. And back to my yellow. He adds 4 black marbles to the bag and says the probability of getting a black marble is 4 out of 16. So this is Jamie. He's saying the probability of getting a black is 4 out of 16, which can be simplified down to a quarter. Explain why he is wrong. Well, let's look at what we've got. We've got 5 reds, 11 whites, and he's just added 4 black marbles. What do we got? We have got 20 marbles, not 16. So Jamie is wrong because the probability of actually getting a black is going to be the 4 he put in there out of 20, which can be simplified down to 1/5 if you look at it carefully. Alright, so that's it. I'd like to tack one more question onto this section of the video, just like doing a little merge. Page 115, there's a really good question involving Jack and his 30 marbles. So we've got 30 marbles here, and he's got some blue, don't know how many yet. He's got some yellow, good job, that colour matches quite well, and he's got some grey marbles. So it's 30. He may have 10 of each, we don't know yet. I've not read the rest of the story, so stay tuned and we'll find out what to do. Anyway, Jack's got 30 marbles, blues, yellows and greys all mixed up there. He picks a marble at random. The probability of a blue marble is 0.4. let's write this down. Probability of a blue marble is 0.4. That could be 4/10 or 2/5 or 40%, but stick to decimals, that's what we've got in the question. The probability of the yellow one, right underneath here, probability of the yellow is going to be 0.1. And I'm not told this, but since there's nothing else sitting in there, I'm going to say probability of the grey marble is going to be 0.4, 0.1, that's 0.5 so far, so therefore the remaining must be 0.5, and that all adds up to 1. That means he is certain to pick something out of the bag randomly. It could be blue, yellow or green. So this is a calculation I've just done. It's not in the question, but I'm probably going to need to use it in a minute anyway. Right, that's all the information I've got, and that's what I've been able to work out all by myself so far. Right, here's the questions. How many blue marbles does he have? Well, the probability of getting a blue marble is 0.4. So the probability, how many marbles he got in the bag? Right, therefore blue marbles must be the probability of getting one marble multiplied by the number of marbles sitting there in the bag. That gives us 4 30s, 120, 12. There's 12 blue marbles sitting there in the bag, absolutely for sure. Alright, B says how many yellow marbles does he have? Same method. The chance of getting one yellow marble, the probability of getting one yellow marble is 0.1. Therefore, if I multiply it by 30, I should get the probability of getting a yellow marble, you know, having 30 goes. So I should get 0.1 times 30. So I'm expecting to have 3 yellow marbles in there. And C says, what is the probability that he'll pick a grey marble? Two ways of doing that. Well, I've done it before, haven't I? These two probabilities add up to 0.5. Therefore, the remaining 0.5 has to be the probability of getting a grey marble. So the way to show I'm working is I take 1, take away my 0.4 and my 0.1 from that, you see? So that's basically 1 take away 0.5, leave me with 0.5 as a probability for getting a grey. And they could have asked how many grey marbles are in the bag. Well, 0.5 times 30 is 15. So if we do a quick calculation, we've got 15 greys, 3 yellows, 12 blues. It all adds up to 30. So we know we've got it completely correct. And that's the question I really wanted to do. And